Okay guys, so just want to show you the proof for the trigonometric Pythagorean identity. So here's what we got. So let's start with the title. Proving trigonometric Pythagorean identities. So now let's start with the coordinate system. So let's start with the x-axis and the y-axis. Okay, so here's the x-axis. And the y-axis. So now from here we want to make a unit circle. So I need a compass. And then I just drag the compass all the way over here, the center, or the origin. And then the radius is about this long. And then we want to make a unit circle. Okay, and then just grab the compass. And now from here I want to make a right triangle. Any kind of right triangle. Not necessarily to be a special one, but just a regular. Okay. So now we do have a radius, x, and over here, y. And then the angle right between the terminal psi and the x-axis. So let's say this one is theta. So one thing that we notice, cosine of theta, it's considered adjacent over hypotenuse. So what we got here is x over r. And then sine of theta, which is opposite over hypotenuse. So for this right triangle, so we do have y over r. And then if you just cross multiply, we do have r cosine of theta equals x. And then over here, cross multiply, we do have r sine of theta, so that equals y. Now, as you can see, that's a right triangle, so that means we can apply the Pythagorean theorem. So for the Pythagorean theorem, a lot of people are saying that a squared plus b squared equals c squared. But instead of using a, b, and c, we're using x, y, and r. If you guys put it in, so we got x squared plus y squared equals r squared. And as you may notice that this one is the equation of a circle with 0, 0 at the origin. So now instead of using x, y, so we're using the replacement r cosine of theta for x. So we got r cosine of theta, quantity square. And then for y, we're using r sine of theta, quantity square. So that equals r square. And then once you square this out, so we got r square cosine square of theta. And then for this one, we do have r squared sine square of theta. So that equals r squared. And then by factoring out that r squared, the greatest common factor, so we take out r squared. And then rewrite it, so cosine square of theta plus sine square of theta. So that equals r squared. So r squared, so we can cancel them out. And then whatever that's remain, just rewrite it. So cosine square of theta plus sine square of theta. Guess what? That equals 1. Ta-da! And here's the one of the Pythagorean identities. And for those you might be wondering, how do I prove the rest of the Pythagorean identity? So here's another 2 steps. So let me just show you that. So we already proved that the basic one, cosine square of theta plus sine square of theta equals 1. So in order to prove the rest of this, so now from here we divide everything by cosine square of theta. Okay, every single term just divided by cosine square of theta. So cosine square of theta divided by cosine square of theta, which is 1. And then sine square of theta divided by cosine square of theta, which is tangent square of theta. And then 1 over cosine square of theta, which is secant square of theta. And here's your other Pythagorean identity. And then to prove the other one, the third one, again, so we go back to the basic one first. So instead of dividing by cosine square of theta, so this time we divide it by sine square of theta. Again, every single term divided by sine square of theta. So cosine square of theta divided by sine square of theta, we do have cotangent square of theta. And then sine square of theta divided by sine square of theta, we do have 1. And then 1 over sine square of theta, again, the reciprocal identity, so we do have cosecant square of theta. And here's the third one. Again, we got number 1, 2, and 3. And for those of you who like the video, so please subscribe to the channel. So in the future, I'm going to put up more math video regarding all the lecture for all kind of subject area for secondary math. And thank you for watching the video today, and I'll see you next time.